What exactly is a likelihood function? And how is it different from probability? In this video, we'll break it down using simple language, visuals, and examples straight from the core of statistical inference. When we talk about likelihood, we're not asking, what's the chance of this data happening? We're asking, given this data, how plausible is a certain parameter value? That's the key difference. Probability looks at data as a function of the parameter. PR, X, same X. The likelihood flips the script. We treat the data as fixed and look at theta, Lth, Fx, Rth. Formally, the likelihood function is Lth, Fxh, Lth, Fx, Rth, Lth, Fxa. It tells us how likely it is to observe the data we actually got under different values. And remember, likelihood is not a probability distribution over theta, it's just a function. That means Lth doesn't have to integrate or sum to 1. We usually assume our data comes from a probability model, say Fx1 For example, for a coin toss, Fx with your Thex 1 your 1x. For normal data, Fx your your NMS2. In this course, we'll mostly deal with i.i.d. data, meaning x1, x2, xn are independent and identically distributed x your 1, x your 2, xn. Text are independent and identically distributed x1, x2. xn are independent and identically distributed in that case. Lth, I1, 1 nf, I3, Alth. Vars, Hanprad, I1 nf xei, I3 Lth, II 1f eat. And the log likelihood is even simpler to work with. To recap, likelihood measures how plausible different parameter values are, given your data. It's not a probability itself, but it's based on one, and it's the foundation of techniques, like maximum likelihood estimation, which we'll dive into next.